Greetings of the day, dear students. In this video, we are going to discuss about the capacitor filter. So this is the most simplest form of the filter circuit. The capacitor will be connected across the output terminals. So here, if this is the waveform which represents the rectified output from a rectifier, right? Now, in this waveform, whatever the ripples or AC component is present, that will be filtered out using the capacitor, using this capacitor. And one basic fundamental is the capacitor will not allow sudden changes in the voltage. The capacitor does not allow sudden changes in the voltage, and how it gets operated is during the conduction period the capacitor gets charged and stores the energy, and it discharges the energy through the load resistance during the non-conducting period. So it used to get charged during one period, and slowly it used to get the discharge. It gets charged and discharged like this. It's all depends upon its time constant tau. How much time period it gets charged and for how much time period it gets discharged. It all depends or will be governed by the time constant tau. Right now, one more other important basic is the capacitor offers the high resistance to the DC components, and it offers the low resistance to the AC component. So because of that, what happens is it provides the low impedance or low resistance path to the AC component. So whatever the AC component or ripples are present in the waveform in the rectified output, that will pass through the capacitor, and will be filtered out. Right now, the discharge period, as we discussed earlier, for how long it will get discharged, for how long it will get charged, it all depends upon the time constant tau of the circuit. Right, so here, if the discharge time constant is very large, for example, if the value of time constant tau is very large, what happens is, without full discharge the capacitor gets charged again. Actually, the capacitor has to get discharged fully, but if the discharge time constant is very large, then what happens? Without complete full discharge, again the capacitor starts getting charged. Similarly, if the value of load resistance is large, if the value of the whatever the load we have connected, and if its load resistance value is large, then also the discharge time constant will be large. So this is going to lower the ripples in the output, right? And if the value of load resistance is small, then obviously the ripples will be more, the unwanted AC components will be more. And if sometimes if the capacitor value is very high, or if the capacitor value is high, then the amount it can store will be high. So because of that, the ripples also will be less, and the value of DC output, pure DC we used to get, will be more. So I repeat again, if the capacitor value is high, then the amount it can store will be high, so the ripples will be less and the DC output will be more. But one more important point here is, for that, in order to make the ripple content low, you should not make the capacitor value very high. There is a limit on how much the capacitance can be increased. Why? Because if it is very high, then the amount of current required to charge the capacitor will be high. So the amount of current required to charge the capacitor will be high if you have chosen the very high value of capacitor. But one advantage is there. What is that? If the value of capacitor is high, right, then it can store more amount of energy, and it is going to filter out the more ripples, right, and the output will be pure DC, right? So here, dear students, in this entire discussion, this is a capacitor filter is the simplest form, right, or simplest form of a filter circuit, where it will be connected across the output terminals like this, capacitor C. So this is the filtered output. With filter, without filter, this is the output. This is the waveform, and this is the output from rectifier, where it converts the AC to the DC. It is going to have the ripple contents. We are not going to get the pure DC. In order to get the pure DC, to filter out the AC component present in the DC, we are going to use the filter, right? And another important basic is capacitors will not allow sudden changes in the voltage, and it's how much time period it used to get charged, and for how much time period it used to get discharged. It all depends upon the time constant tau of the circuit, right? Thank you.